All right, class, we're on page 2, where we're going to really distinguish between population and sample and what kind of information we get off of those two things. So, two new vocab words, parameters and statistics. A statistic is the number that's described in a sample. So think about statistic S, sample S, so that can go hand in hand. A parameter is the number that's described in a population. So think parameter P, population P. So you can connect those two things, okay? And let's take it a step back, right? What's the difference between a sample and a population, right? Population is everybody in the chosen field that we're studying, and then the subgroup, the smaller subgroup that we take from the population, that's your sample. So think of the larger scope to the smaller scope. And now we're even taking that a step further with talking about a sampling distribution. So in a sampling distribution, we have all the possible samples, right? Depending on what size sample we get, all right? So we're taking a bunch of different samples from that group. Instead of looking at the whole population, we're just keep grabbing samples and then we map those out by looking at the statistic, either the sample, the number that describes the sample, either like the proportion or the mean, and we map those out, okay? And that's a sampling distribution. So you want to pay attention when you're looking at these things. Which distribution are we looking at? Is it a sampling distribution where we're looking at all the outcomes from all the samples, right? Or is it a population distribution where we're looking at all the individuals? Think about population distributions where the stuff that we were doing in chapter 2, when we were looking at normal distributions, those were mapped out off of every single individual. In this problem set, we're going to start to look at outcomes as samples, because in real life, you don't just look at a whole population. It's a lot easier to grab samples, and that's how you can make your conclusions, and that's enough using statistics. The other thing that you're going to start to notice here, class, are these symbols. All right. When we talk about parameters for population, we're going to be looking at means, which is averages. That's that U looking thing, the mu. If it's a proportion, it would be straight P. Or in the standard deviation, there's that symbol, that epsilon symbol. All right. I think that's what it's called. Anyway, for statistic, there below, you're noticing that we use different symbols because the statistic is off of your sampling or your samples. We use X bar to talk about the mean if it's a sample mean. There's a hat above the P if it's a sample proportion, and then just straight S for a sample standard deviation. A way to kind of remember that S sample, that kind of thing. All right. So let's take a look at an example here. All right. And we're going to highlight some information that we care about with this. All right. So start with the beginning. To determine how much homework time students will get in class, Ms. Lynn has a student select an SRS of 20 chips from a large bag. SRS is short for simple random sample. All right, random sample, that's a good start, right? An SRS. All right, the number of red chips in the SRS determine the number of minutes in class students get to work on homework. All right, so however many red chips the student pulls out, that determines how much homework time they get. Ms. Lynn claims that there are 200 chips in the bag and that 100 of them are red. When Jenna selected a random sample of 20 chips from the bag without looking, it's random, she got 7 red chips, which I'm assuming means that this class got 7 minutes to do their homework. Does this provide convincing evidence that less than half of the chips in the bag are red? So we could probably take this a step further and start to speculate, is, Miss Lynn kind of telling the truth that there's 100 chips in the bag, but we're not going to get into that piece yet. We will get into to like that question where we're answering the evidence piece, but right now we want to be able to sift through the information that's given and know the different pieces so that we can now have a better way to get to that question where we can actually now talk about evidence. Okay, so we're going to actually just focus on what information do we have in this question. So let's start there. All right. What's the population in this group? Well, the full bag had 200 chips, right? That's the full population. I know we're talking about minutes and homework time, but that's represented by these 200 chips. That's the full population. So if I think about population, 200, but I don't want to just say 200. 200 what? We have to have context. It's 200 chips. All right. Then from there, I can go down to the sample. Sample was the subgroup that we took from the population. And how big was the sample? It was 20. We had an SRS of 20. So you should look for that kind of language in there. And don't just say, the sample was size 20. It's 20 what? 20 chips, and they were randomly chosen. If that information isn't there, the random piece isn't there, then 20 chips is enough. We're talking about the sample. So starting there, knowing how big our population or what the population is. Sometimes you won't have a number, but you'll know like it's all chips or all students, that kind of thing. That's enough. And then what size was your sample, and who is in the sample, right? So that's important. Now let's go to the actual like information, the numbers that we would be able to collect off of these two different things. Now the parameter, notice the parameter, that symbol that we use is P, because we're talking about proportions, not means, right? The proportion in this case is how many red chips are there, right? We're looking for red chips in the bag. And in this case, we were told that there were 100 out of 200, and that's where you got your answer for the parameter. Sometimes you're going to get a question where you don't actually have the population information, where you would just then say P equals, the true proportion It's not how you spell true. Let me fix that. So if you don't have the actual numbers for your population, you would write it out and give me the context. So what does P represent in this case? It's talking about the true proportion of all red chips in the bag. That's population. We say true as like a way to talk about the actual population proportion or population mean, depending on what you're talking about. So that's the language we would use if we didn't have the numbers. All right. And that's important that we use the correct symbol. So P is the correct symbol there. All right. And then we can now look at the statistic, which is what we would be talking about for the sample. So what was the outcome in our sample? We have the statistic. Well, first of all, what's the correct symbol? Since we're dealing with proportions, that's P hat. Very important, right? Notice the difference. So P hat in this case was the outcome of our samples where we got 7 red chips out of the 20. Okay, so 7 over 20 is 0.35. So that's our sample proportion. Because we use the right symbol and the correct numbers, we're good to go in identifying this. And then this would be the information we could then start to use in answering that next part, which is there convincing evidence? I'll explain the rest of this in another video, but here you have how we distinguish what is what in a problem, which is the first step, oftentimes the most important to getting you on the right track.